Hi. So what we're going to do in this video is look at the equations of a line when we're dealing with vectors. So this is a lot of information all of a sudden. So I'd maybe suggest, I'm going to pause, well, I'm not in the screen, so maybe I need to screenshot it now and then maybe afterwards when I've done the example, because it is a lot to remember all at once. But the thing is, if you can remember part of it, it allows you to, if you can remember one of the forms of an equation of a line, you can develop the other two from it, basically. So it's not like you need to memorise all of it as long as you're able to work out the other versions. So starting from the vector equation form, our r equals a plus a parameter. I use that symbol, Greek letter lambda, I think it's lambda, and then u, where r equals any point on the line, so x, y, z, any, so that's going to be x, y, z in that case. A is a known point on the line, so that's something we do know, we know those coordinates. That symbol, which I'm saying is lambda, I think it's lambda, is a scalar parameter. So it's going to, for the most part, stay as that scalar parameter, it's going to stay as that symbol. I've seen S's used, I've seen T's used, I've used this. Really, as long as it's a relevant symbol that doesn't get confused, it's fine. And then U is a vector parallel to the line. What I mean by that is you can either have a vector parallel to the line or a vector that goes through the line because they are the same. Okay? So that is a vector equation form. From that, if we will go across to the parametric form, from r equals a plus lambda u, we can then get x, y, z equals x1, y1, z1 plus lambda abc, leading us to, if then we separate those variables into the different parameters, we can get x equals x1 plus lambda a, y equals y1 plus lambda b, z equals z1 plus lambda c, which allows us, that is the parametric form, so having it in that system or array of equations. And then from the parametric form, we can then get the symmetric form. So rearranging for the parameter lambda gives us lambda equals x minus x1 over a, lambda equals y1 minus y1 over b, and lambda equals z1 minus z1, z minus z1 over c, where then we can express it as lambda equals x minus x1 over a, equals y minus y1 over b, equals z minus z1 over c. So those are the three different forms. So what I'm going to do is I'm going to go through an example showing you how to get from the vector equation to the symmetric form. So the first thing I need to do, I've got 2 points. So I've got the point, I need to know a vector on that line. So that's straight away easy enough. And then I can just write down the equation. So there, I've calculated vector PQ, and now so remember A is a known point on the line. So there. Now as before, depending which point of the line that I'd used, we would have a different answer, but that's the whole point of this, is vectors go on for infinity, so we could have multiple different answers, all depending on which points we use. And that is what the parameter allows for, as in the parameter allows us to calculate effectively for whatever point we're using. So then, taking that onto the parametric form, I can then convert that, the vector form, into the parametric form. So there, straight away, it's actually pretty straightforward to read off from the vector form what the parametric form is. So it might have looked complicated with all the words and all the different types, but it's actually really straightforward once you get used to it. And then lastly, I can then convert that to the symmetric form, firstly by rearranging for lambda, and then making them all equal to each other. there. We've got x, lambda equals x minus 2 over 2, lambda equals y minus 1 over 3, and lambda equals z minus 1 over 5, and then setting that all out, we get lambda equals x minus 2 over 2 equals y minus 1 over 3 equals z minus 1 over 5. Okay? So a few things to note about this, if we could think about it, because we might often get given the symmetric form. So if you remember that a, b, and c from the parametric form were a vector, okay? So if you're given the symmetric form, then you can read off that the denominators of the line are a vector parallel to the line or within the line, whereas the numerator numbers, constants, are not going to be a vector, but they're going to be a point on the line. And recognizing that is going to help you solving these questions. And again, we could do that for the parametric form. So the coefficient of a lambda is a vector, and the other number is going to be the point. Okay? So that is the three different equations of a line.